Today we are going to look at two interesting exercises about plotting points or regions on the coordinate plane defined by absolute values and inequalities. If you're not confident with graphing points and line segments on the coordinate plane, I really encourage you to watch my previous 3 videos. Graph the points x, y in the xy plane that satisfy the condition xy is less than 0. Do you have an idea how to solve this problem? Feel free to pause the video and think about it. We have to ask the question, when is the product of x and y less than 0? In other words, when is the product of x and y negative? We know that the product of two numbers x and y is negative when x is positive and y is negative. Or when x is negative and y is positive. In other words, xy is less than 0 when x and y have different signs in front. The only thing we have to do now is find the regions on the coordinate plane where x and y have different signs in front. In the first quadrant, x and y have the same signs in front. So this is not what we are looking for. In the second quadrant, x is negative and y is positive. So we can shade this region because the product of all x and y in this region is negative. So the product of x and y is less than 0. What about the third and fourth quadrants? I highly encourage you to pause the video and try this on your own. In the third quadrant, we have two of the same signs in front of x and y. So this is not interesting for our problem. What about the fourth quadrant? Now we're in the ballpark. The x-coordinates of these points are positive, and the y-coordinates of these points are negative. So the x-y coordinates of all these points in the fourth quadrant have different signs in front. So we can also shade this region. Because the product of all x and y in this quadrant is less than 0. What we have to do now is to dash the lines on the axis because 0 is not included. In other words, the condition is less than 0. It's not less than or equal to 0. So these regions in the xy plane satisfy the condition xy is less than 0. Let's look at the other example. Graph the points x, y in the xy plane that satisfy the condition the absolute value of y is greater than or equal to 2. What does it mean that the absolute value of y is greater than or equal to 2? It means that either y is greater or equal to 2, or that y is greater than or equal to negative 2. Let's try to understand this better. The absolute value of 2 is 2, and 2 is greater than or equal to 2, right? The absolute value of 3 is 3, and 3 is greater than or equal to 2, right? The absolute value of 4, and so on. What about the absolute value of 1.9? The absolute value of 1.9 is 1.9, but 1.9 is not greater than or equal to 2. So the absolute value of y is greater than or equal to 2 when y is greater than or equal to 2. So this is correct. Let's try to understand this part better. The absolute value of -2 is 2, and 2 is greater than or equal to 2, right? The absolute value of -3 is 3, and 3 is greater than or equal to 2, right? The absolute value of -4, and so on. Again, what about the absolute value of -1.9? The absolute value of -1.9 is 1.9, and 1.9 is not greater than or equal to 2. So this is also correct. So the points can be represented by the two shaded regions. We use solid lines to represent that the points on the boundaries 2 and -2 are included in the solution set. The reason for that is that we have a greater than or equal to sign here. And not the strict inequality greater than. So these regions satisfy the condition the absolute value of y is greater than or equal to 2. If you have any questions, feel free to ask me in the comments. This video is what I did for you. If you want to do something for me, hit the bell button, like, share and subscribe. Thanks for watching and happy learning, everyone.